Antenna analyzers are arguably one of the most useful pieces of test equipment you can have on a workbench or out in the field. While a basic SWR, that is standing wave ratio meter, tells you if there is a mismatch between your radio and antenna, an antenna analyzer tells you why there is a mismatch and exactly what to do about it. NanoVNA is a small portable antenna analyzer which is quite affordable to any ham. Of course, there are more costly, sophisticated ones as well. For anyone doing more than just plugging in a commercially bought pre-tuned antenna, antenna analyzers are not just useful but essential. Pinpointing resonance and impedance. A standard SWR meter requires you to transmit a signal, creating QRM on the band, and only gives you a ratio. An analyzer generates its own low power tiny signal, allowing you to sweep a wide range of frequencies silently. An antenna analyzer shows you the exact frequency where your antenna is naturally resonant, where reactance is zero. If you are trying to force an 80 meter dipole to resonate down on 160 meter without increasing its overall length, an analyzer takes out the guesswork. It will show exactly what the complex impedance R plus minus JX is at the feed point, letting you calculate precisely how much inductance you need to add via loading coils to cancel out the capacitive reactance of the shortened antenna. Tuning a single band wire dipole by snipping the ends is easy enough, but tuning a Moxon-Yagi hybrid for satellite work or adjusting a trapped vertical is a different story. Adjusting one band often detunes another. An analyzer allows you to see the resonant dips for all bands simultaneously or quickly switch between them, saving hours of frustrating trial and error. Modern analyzers, particularly vector network analyzers, that's VNAs, like the popular and inexpensive NanoVNA, go far beyond just testing antennas. They are incredibly powerful tools for homebrewing electronics. Filter sweeping. If you are building a transceiver from scratch like an ECBTX or constructing a 100-watt linear amplifier, you can use the analyzer to sweep your low-pass ladder filters. It will graphically display the insertion loss and verify that the filter cuts off exactly where it should before it goes to the antenna connector. Measuring components. You can use them to measure the exact value of unknown capacitors or find the self-resonant frequency of inductors and RF chokes. Checking coax. Analyzers can measure coax loss, determine the exact electrical length of a feed line, vital for phasing harnesses, and even use time domain reflectometry to find exactly where a coax cable is broken or shorted. Because an analyzer generates its own tiny signal, you don't need to key up your transceiver to test an untested, freshly built antenna. Keying up a 100-watt rig into a dead short or an antenna with massive SWR can immediately fry the final transistors. An analyzer protects your expensive radio gear from being the test dummy. If you operate only occasionally, that too on a factory-tuned antenna, you might get by with a built-in radio SWR meter. But if you cut your own wire, experiment with shortened antennas, or build your own RF circuits, an analyzer will pay for itself in saved time and saved finals.